For centuries, humans have been trying to solve some of the most difficult problems, complex problems, that despite their best efforts, they often came up short, until that is the advent of computers and coding. Now with the help of recursion and binary trees, it can solve a lot of hard problems, these humans. Now, if you're new to the world of computer programming and the terms recursion, binary trees, binary search, you heard them before, but you don't really know what it is yet, this video is for you. So let's break down these concepts. This is coding concepts. We break down the concepts. Sometimes we make code out of it. So let's make it an easy to understand video as much as possible. Recursion and binary trees can be used to solve problems in computing. Here's how recursion works. How binary trees store and organize data. How recursion and binary trees are combined to solve complex problems. Applications of recursion and binary trees in artificial intelligence. Recursion is a technique of defining something by its own terms. It's a very powerful concept. It's a way of thinking. So simplifies the concept into smaller and smaller and more manageable pieces. You got a big chunk of a problem, cut it in half, then that half, cut it in half. That's defining it by itself. I got 100, do a half of that, that's 50. Do a half of that, 25. Do a half of that. A real world recursion would be like a matryoshka. You know those Russian dolls? It's a set of dolls. It gets smaller and smaller. Take off the top. What do you have? Another one. Take off the top. What do you have?
Another one.
You take a step and then you look back to see, what do I do now? And back there is whatever you did before. Oh, I took a step. So you took another step. Then you turn back and go like, what do I do now? Well, what did you do before? Oh, I took a step. Like an echo. You know fractals? Fractals pattern? The Mandelbrot set? Made with recursion. It's a simple equation. It's used over and over and it creates awesome self-similar shapes. The Mandelbrot set. Recursion. Think of branching. The branching tree structures. Structures of blood vessels in the body. The network of roads in a city. Recursion. The Fibonacci sequence. At some point, Dan Brown talked about it in the Da Vinci Code and then you saw it everywhere. It's a powerful mathematical concept. It says start with 1, then put another 1, then do the sum of the preceding 2 and that's the next one. So 1, 1, 1 plus 1, 2, 2 plus 1, 3, 3 plus 2, 5. So see we're like, what do we do? What do I do? What was that before? Oh, okay, so me plus the one before. That's the next. That's recursion. It's like magic for solving problems. Sometimes you got a problem in computer science, you're like, can it be solved recursively? You either have two choices when you have to do something more than once. It could be iteration, so you have with iteration you have loops where you go like, okay, let's do it up to 10 times and then at 10 you finish. Okay, I do it 10 times. Recursively is like, it's up to whatever you got going on. You know, it could be infinite. That's why it creates a stack. And it's a stack is a data structure. We'll talk about data structures in another video. But every time you recursively do something, then the computer creates a stack. And that's sometimes when the flow has too many instructions, the stack gets too full and then it overflow, and that's what Stack Overflow is. And that's the name of that website. Binary trees. Binary trees are a type of data structure. You know data? You know structures? Data is structured in a way. In what way? Many ways. One of the binary trees. They have nodes and the node contains data. There's a data field, you know? And then starts here and then either left or right. Either you point left or you point right. Binary. You point to a node that contains data that is less, or you point to a node that contains data that contains more. Right contains greater than the previous data. The left one contains data that is lesser than the previous node's data. So you see how binary trees can be recursive. Binary search is an algorithm that is fast and efficient. It's how you search for a specific element in a sorted array of numbers. It has to be sorted. There's algorithms to sort that too. The sorted array. Cut it in half, then check if the element you're looking for is in the left half or in the right half. If it's in the left half, then that half, cut it in half, repeat the process. Whenever you repeat a process, there's either iteration or recursion. In this case, recursion. So you repeat the process on that half. You keep doing this till you find that the element you're looking for is right there, or you've searched for the whole thing and then you got nothing, but at least you know it's not there. So it's like you're cutting down a tree branch by branch until you find the perfect stick that you're looking for. There's a binary tree. The roots are on top in this tree. It's like reverse. Each node splits into 2 smaller nodes till you find the element you're looking for. Recursion and binary trees are hugely important in the world of artificial intelligence because they help us build systems that can think and learn like humans. Let's take a look at some of the ways they're used. Decision trees make a decision. They're a type of binary tree that are used in machine learning and decision making. You think of the tree as a map, and each node is a decision, and each edge, which is the edge is the thing that connects one node to the other, that little stick in between the 2 little balls. Each edge is a possible outcome. So you follow the tree from the root to a leaf, and you make an informed decision. In decision science, data scientists build machine learning models to make decision. When it comes to playing games, in computer, they use recursion and binary trees, and the game is represented as a tree. Each node is a state, and each edge is a possible move in the game. And that's how systems learn how to play pinball or chess. Recursively, the computer finds the best move to make when it plays against past games, and then it plays against itself millions of times. Neural networks. They are an AI technology that is inspired by the structure of the human brain. They use recursion and binary trees to represent the connection between different neurons, with each node representing a neuron and each edge a connection. And recursively, they process input data, and the neural network can learn and improve its performance in the output, decision making. Recursion, binary trees, artificial intelligence, complex problems, solutions to them, decisions, making decisions, explore all possible solutions quickly, efficiently, invaluable tools in computer programming and artificial intelligence. Some problems you can never resolve with code, no matter how efficient the algorithm, like the halting problem. We'll talk about that.